We all good?
Okay, so for anybody who's joining a video recording of this, my name is Levi Schuck. I currently work at Eat Street, but I am just learning Elixir on my own time. So what I'm going to show here is a very basic combination of making your own library code, using other library code, and integrating it into a very simple Phoenix app. The application I'm going to be making in front of you guys is a basic scraper for Hacker News. So the first thing we need to do is actually to make a project folder. So if you already have Phoenix installed, you can use it out of the box, kind of like how NPM can have global modules. I'm going to say Phoenix New and a name. I'll say Hacker News or Hacker Page. But some other options that I'm going to use here is just to say I'm not going to use a database and I'm not going to use any front-end library stuff. So I'm going to say no ecto, so I don't import any database stuff since I'm not running Postgres on my machine. And I'm going to say no brunch so that it doesn't do any special front stuff for me because I have a very old NPM and Node version installed. So with this, it's going to create a new package folder with several things ready. As you can see, it has several web views, templates, and so on. We're not going to fuss around with that too much. For now, I'm just going to say that it's going to go inside, and we'll start coding with this. I'm going to open up an editor. And the first thing that we want to look at is our mix.exs file. This describes the dependencies of your project, how it should run, and so on. There are a couple dependencies required in order to use my library as well as some others. First, I'm going to add the standard libraries, which are actually available in the package manager that Elixir uses, which is called Hex. So I'm going to say Floki. This will allow me to process HTML kind of like jQuery. The current version just happens to be 0.17, so I'm going to type that manually. I have another library that I need named HTTP Poison. This will allow me in Elixir to do web requests, basically like curl. I'm going to need gproc, which is used to find processes, and it's general, which is, I guess, what the G is for. I will need this because I should have actually imported it with Slow Scraper, but I haven't. So I'm going to say 0.5 for the current version. And finally, I'm going to import or require a GitHub repository since I don't have my package published yet as it's still in development. It's called Slow Scraper. This will allow me to slightly cache what I request so I don't spam Hacker News and take 3 seconds every time I want to refresh the page. So in order to require a package from GitHub, Hex already allows you to basically type GitHub, the package repository, and you can use tags or branches. I'm just going to use master for what I currently have. So now that I have some dependencies installed, what I need to do is to, or rather dependencies specified, I need to install them. To install dependencies, you need to do mix deps.get. So mix is like your gateway application like NPM to do many things. So now I've requested several of these repositories, or rather packages from Hex, as well as mine, and it also gets the requirements that they have as well.
So Mix is the package manager, but Hex is like the dependency resolver, or how does that work?
Well, Mix is a very general application that you can have tasks associated with, and there are released tasks that are pre-installed when you install Mix. And some of those tasks, like dep or deps, can do those kinds of operations for you.
So just a build tool.
Yes.
Yeah. Cool.
So Now, what I can do is to actually try to.
Sorry, can I?
Yep.
One more question. The tasks that get the deps, is that provided by Phoenix, or that's a wholly separate thing that just happens to be present?
The dependency getter is just installed with Elixir. It
Okay.
doesn't depend on Phoenix. So if I want to go inside of my server and start running and probably use the REPL a bit, I need to use IEX, which is like IRB if you've done Ruby. It's interactive Elixir. Then I'm going to provide a command with -S to actually run what I intend to do inside of it. So I'm going to say mix phoenix.server. And what this should do is it will start the server. Now, the first time that you start your project, it's going to have to compile these things because Elixir is a compiled language. It compiles to Beam bytecode. It's not script-like. However, there are scripty files that can be reinterpreted on the fly. We will get to those later when we do the pages. So now, if I go to localhost 4000, let's see here, make a new page, come on, new window. You can see here I've got my hello world of Phoenix, but we're not going to worry about that just yet. I'm going to start making the actual Hacker News code that will go and look at this stuff. So what I need to do is create a new module. I'm just going to call it hackernews.ex. The general way of naming is that you do your modules in camel case, but the file names are snake case. So I'm going to do def module, Hacker News. And then from here, I'm going to start doing some stuff that is particular to the style that I've kind of figured out lately. I'm not necessarily recommending it for production or anything, but I'm still experimenting around. So one of the first things I need to do is to actually say, I want to use Slow Scraper, how am I going to do it? So I'm going to make this definition called client spec, in which I'm going to basically refer to the kind of constructor of Slow Scraper with some pre-built parameters. So for now, I'm just going to say my headers are empty. I could say refer is Hacker News or Google or something else. And then I'm going to return, which is the last line in this function, Slow Scraper, client spec. My library just happens to use the first parameter as a key, so I'm just going to say HN. This can be any arbitrary term that we'll use later to request stuff at runtime. So I'm going to say headers. You could put whatever you want there for any initial configuration. And I'm going to give it another module name, which I'll make in just a moment, which implements a behavior. A behavior is like a contract or an interface.
Typo on the module definition.
Let's see here, where?
Hacky News, line 1.
Oh, thank you. So within my HTTP module, which I can define within another module, I'm going to define something that is actually part of it. I could do like at behavior slow scraper.adapter, and this will enforce at compile time that you have all the required functions and they have the right amount of parameters. You can add any other parameters. You can have additional behaviors as well. It's just like an interface. So I'm going to say def scrape, which is part of what is required. So it comes with two parameters. One is what's provided at initialization, and this is always constant, and the second is what the user provides. It could be a term, it could be a string, but for now, we're just going to use strings. So I'm going to log that I am being requested the URL, and for now, I'm just going to return hello world to the outside. I'm not going to do any requests just yet. Now, if I want to get information out, I need to make basically a public function to access some of that information. So I'm going to make another function in Hacker News called getNewestPage. You don't have to add empty parentheses when you're doing a single or a zero arity function. Some coded styles like it, some others don't. Anyway, so to actually get that information, I'm going to use my library here. A public function which I have called requestPage. Now the term I have above here to identify this instance in memory is called HN. I'm going to refer to it here. And then I'm going to give it a URL. And then I have a couple extra parameters. One is how long should something stay in memory before it's stale? How many times can it be stale over time? And how long am I willing to wait for the answer if it's already been loaded? And this is just going to be it for now. Now, if I actually tried to run this, you'll see that I've missed something. It says here that I must require logger. That's because down here, logger is actually a macro for this function called info. Macros are evaluated at compile time, so I could have in my config file up here somewhere, I could say that the log level is for production warnings only. But to get across that, I'm going to say require logger. And now I should be able to do Hacker News. Oh, it doesn't look like it's loaded, so I'm going to go kill it real quick and jump back in. Now I can access the function that I made earlier. However, it will crash, and I will show why. So we have a couple requirements here. gproc is actually its own application that has to run in the background, so you actually have to tell it to start. So we're going to jump back to the EXS file and look at something above here. In your definitions of your application, you also specify what dependent applications must be started. In this case, I have a couple things I need to add, namely gproc, which is used to keep track of processes, and also HTTP poison because it has its own way of keeping track of workers in the background so it doesn't like spawn new processes continually.
Zach, you have a question?
Yeah, so what is, so can you elaborate on the nature of the application abstraction here?
So the Erlang world is a little different in that of how libraries and applications work. So applications means that you need to have some sort of initializer happen, some sort of supervisor structure happen. Basically, it's not just you call it and then it lazily starts itself. This is kind of like static initialization if you do C++ stuff or other things like that. And if you use what are called library applications, they're really just libraries and you don't have to start them. So I have Floki down here, but I'm not going to be putting it up there because it doesn't need any of its own processes at runtime.
Okay. So you said earlier that the logger call is itself a macro as opposed to like a module?
So logger is a module, but .info is a macro exported by that module. So I have to tell it to actually require it, and by saying to require, this actually forces it to ensure that the logger module has been compiled before it compiles this module.
Because it wasn't an explicit dependency, the same way like slow scraper was. It's not.
Logger is kind of a dependency, but it's not third party.
Right.
It comes with Elixir, just like how kernel comes with Elixir. But if you're using Basho's lagger, which is what they use for distributed logging, you would have to have it down here, and you would have to have it up here.
Cool.
Okay, so going back, now that I have gproc inside of my application stuff, this is actually something that will require me to restart the virtual machine. So I'm going to quit out and start it up again.
More question.
Okay.
So you got that argument error on gproc. Is there any way to, how do you parse that error, figure out that you don't have a particular application running?
So ETS, this does require a little bit of knowledge about the Erlang runtime, which is ETS comes with Erlang, and ETS is Erlang term storage. It's an in-memory database, and the way these in-memory databases work is that they have to be associated with some sort of process. So here, gproc where was unable to find a process because ETS lookup, the first parameter is actually either a PID or a term, or rather a keyword, or an atom, or whatever you want to call it. So in Erlang, you can use atoms like :gproc to identify a unique single process. And since ETS was unable to find that unique single process, it failed and threw an argument error. If I do the same as before, I'll have another error. So this is because I have not started my client specification yet for my process that is in my personal library here. So I made that function before called client spec, but I never used it anywhere. So now is the time to use it, and this is where we start making our own supervision tree. So you usually have what's called an application module with your package. In this case, it's called hacker page. And you'll see stuff like type and args. You think of this as like argc, args when you're doing like C or Java, and you're doing the main initialization. So I require a couple things before I actually let my endpoint start up, which is what Phoenix uses. Namely, I need to start my Hacker News client. So I named it client spec, and it returns from Slow Scraper its own client spec, which is basically something that can be stuck into a supervision tree. So
is client spec a?
It's a function name I made up.
Oh, okay.
If we want to dive into what it looks like inside of Slow Scraper,
Yeah, I was going to ask at some point.
I was more wondering if that was like an idiomatic name for things that provide that.
I'm exploring myself.
Gotcha.
That's why I said I don't necessarily recommend this for production. But if you wanted to make your own, essentially what you would be throwing into the supervisor thing is either another supervisor or a worker. Those names come from the supervisor.spec module. If you import a module, what happens is all of those functions become available without a prefix. So I basically specify, here's my module, and here's my initialization parameters, and off it goes.
Okay.
Can you define what is a supervisor and what is a worker? I'm not familiar with the term. Like what they do, what do they do?
So supervisors, they don't run much user code. They only do, they basically watch workers and and nested supervisors for failure. So if you have a worker or an endpoint that crashes and your handler process that resides in the VM terminates, it can restart it. Now, if that process fails like 30 times in less than 10 milliseconds, something really bad is happening. So it itself will start giving up. And supervisors can also have different strategies. So perhaps if one process in the middle of the list dies, maybe the rest of the processes have to die. Or maybe if one of them dies, all of them have to die because they were intimately linked together. You can use gproc to make it so that you don't necessarily have to rely on that, because gproc will allow you to look up the PID every time. So now getting out of my library and back to our application here, I just added the client specification. So now Hacker News will start its own client before the rest of the server can start. So once more, I restart the virtual machine. And now, if I paste that again, I should be able to get a response. But this time it will just say, hello world. So as you can see, now my process or my code has hooked in through this library to request this page. It didn't actually get the page necessarily, but obviously this happened. Now, because I wait a while before saying something is stale, because of this is the behavior of my library, I can keep requesting it, but it's not going to be stale just yet. After 10 seconds, however, it will say that it is stale and it will request a new page. But because I said I'm not going to wait any time, it in the background will request a new version of that page. So this way, whenever you eventually when we make requests to the Phoenix app, we're not necessarily hammering Hacker News on the URL for each individual user visit. This is just something in the background that's cached. But we're also not going to wait for Hacker News to get back to us, because we still have something in memory that may be of value to the user.
Which method is doing the logging, the requesting?
That would be logger.info. So now, at this point, I'm going to start throwing in how to actually use HTTP poison. So, again, this you can think of this a lot like using curl, and it returns usually tuples. I'm going to assume that there is no failure by basically following the let it crash methodology that Elixir and Erlang has. Basically, code according to what you expect to happen, and if something bad happens, just let it restart. Because usually, if you're well experienced in the programming world, you find that a lot of your bugs is actually in your catches as well, and your validation code. So it's kind of assume it's valid and verify it over time, and if things come up that are wrong, then just crash and in the resulting catch or whatever you have, give the, hey, something bad happened, result. Now, if you need to do different actions because of how things work out, then you want to use cases or you want to use catches. But I'm not going to be focusing on that for this discussion and presentation. So to actually call it, I'm going to use the actual module name, HTTP poison, and I'm going to provide a URL, some headers, and another parameter that basically has the payload that I'm sending. I'm doing a GET request, so I don't really have much of a payload to provide. The next thing I want to get is the body. So I'm going to do access syntax, which is where I attempt to get, like, I could say .body, but what if it doesn't have a body? Then I'm going to crash. But it's acceptable if it's nil. So I'm going to use this access method, which basically uses brackets to look sort of familiar from other languages to access it. And then finally, I'm going to use floki.find. So this is essentially like jQuery when you want to search for something. And I'm going to give the element ID here, hn main. So now if I recompile and I use Hacker News again, I've gotten a whole bunch of text. Well, clearly I didn't type something totally right, but it still got something. Let's see here, response fetch. Okay, I guess it doesn't have the access protocol, and that's where I go to the next thing. So I say map.get, response, body. So sometimes your result is going to actually be a struct as opposed to a map. But structs are maps. So you can do this. But I just don't want to mess around with pattern matching on what type of struct I'm getting, because I might get a success one, I might get a failure, I might get a 404 or something else. Whereas if I got an error up here, that means that maybe the server didn't connect. So that's just a couple different ways to think about it. So I'm going to recompile once more. And I'm going to do it, and I apparently am in the wrong tab here. Let's see here. Well, we can try this. Let's restart it and hope for the best. Aha. Okay, so now I have some structured data that came back, which is basically an AST of the HTML. Now, this is useful because I can do this again. I can do it again, I can do it again, I can do it. I could keep doing it, but I'm not actually making requests to Hacker News. Now, again, like before, it will do it once more if I wait a while. And so there's the logger saying, oh, here's the stuff I found, which is what this line is doing, which I don't need anymore. So now that we've got the newest news page, how are we going to actually get the information out of it? That's where I'm going to say, I'm going to use pipe to parse. This essentially is the same thing as writing parse, slow scraper, inside of it. But by using the pipe syntax, I can do other chaining that makes it so I'm not having to do like other thing, and it becomes hard to read.
It was.
Yep. So I'm going to make a function called parse news, and I'm not going to provide any parameters here because the pipe syntax puts it into the first parameter. If I have other things, I can start making a second parameter, which is like here and here. So now I'm going to make my parse news function.
So if you're passing anything, does that default become the second parameter?
Yep,
Okay.
and third and so on. So I want to find all the things in the Hacker News page. Well, it turns out that they actually call it a thing. So I'm going to say floki.find hnpage dot a thing. So this will find me every element in the news page. Let's see here. Yeah, so I guess, yeah, we're seeing a thing for all these things. So I'm just going to go here and say pipe none.map. Just for now, we're going to go and request the text. So I could say floki.text of my function. So I'm just doing an inline lambda here. Or I can do the short syntax where I refer to it this way. So the short syntax is where the first parameter is and1 and so on. So I can recompile. I can run it again. So now I've got some information from the front page on what's the newest thing. So one of the things, I guess, is this, for example. But we're just doing simple toText or .intertext or whatever you want to call it as an equivalent. This doesn't actually give us the URLs and other stuff like that. So we can do a little bit more complex parsing here. And again, I'm going to use an inline lambda to start processing this from the inside. So the actual link happens to be called with a class name of .storylink. So I can refer to the news, I guess I'll just say new item, with .storylink. I can get the title, which is actually going to be of the same element as the link. So this finds the element, but I have yet to actually get the href. Floki, because of how it works, it's always working on arrays. So in order to get the href, I would have to either destructure the array, but I can also say list.first. So I'm going to say Floki.attribute of the link, href, and then I'm going to say pipe to list.first. One thing to note is list.first does not crash if the list is empty or it's not a list. It will just return nil, whereas some other languages will crash. So I'm going to make a map here of my information over time. So I'm going to say, I'm basically going to make a map of these two variables here. So if I recompile and I run this again, now I have some structured information on each individual element that's in there. I have a title, I have a link, and now I can start doing something interesting if I want with Phoenix. So this is where I'm going to start bridging over to how do I integrate my library code with my view or endpoint that I made. So the first thing I'm going to do is jump to the view, which will be under the web folder. Or rather the templates. So the view is the actual Elixir code, and the templates is the scripted HTML that you can use. So here I have my index.html as a couple things. I don't really care about the stuff that they threw at me at the beginning. So I'm going to cut that out. I'm going to make a panel on the side that's only half large. And I'm going to call it newest. And here's where I'm going to actually show some links. So I can say UL for an ordered list. And this is where we start doing the interpolation kind of syntax. So it kind of has this weird syntax where I don't have the rules myself memorized, but just do as I do for this short presentation. So you can use this sort of macro that's built into Elixir to iterate over things by assigning them to a variable name. This would basically be like a num.map with an inline lambda, but it doesn't have to be as verbose as that. So I'm going to use a, yes. So I'm going to use a function that I've yet to actually make that I'm going to call newest, hn newest. And you actually have to end it at some point. So this equal sign usually means that the value of this is what is to be inserted into the HTML.
Ruby has an identical syntax for interpolation in HTML
Okay,
called ERB. Exact same characters.
that is very helpful then for those who are familiar with Ruby.
Mm-hmm.
So now I need to stick in things like, okay, what's the URL? So the news item is, as I named news, and I have access to it here. I'm going to call it news.url, and I want to insert the title. And I could save, and it's probably going to crash if I try to visit it. The next thing I need to do is to actually create the function called HNNewest. So I need to go to my view, which is under the views folder, and the thing that's available right now is just page.view as it's a, I think it's hierarchical, but I'm not sure. So I'm going to make a function called HNNewest. And I'm going to use the library code that I just made called getNewestPage. And this will basically allow me to pass through. I could process it later. I'm going to show it right now of how it looks. As you can see, it's really long and it's not as suitable. So I'm going to do something real quick and say enum.take5. This will allow me to shorten this list to only 5 elements. And it looks like it auto-reloaded, which was nice.
Whoa.
Yeah. So Phoenix comes with some auto-reloading features.
Oh.
So if I say 10 and I save, I guess it's going to do that. So anyway, so now.
So this abstraction is a view model? There is a presenter?
I'm not sure what to call it.
Interesting.
Is that a general one for all views on in your application, or like that method you just defined is available everywhere in the views?
I wish I could answer you, but I'm not the most familiar with Phoenix yet.
That's
I
fine.
just made this happen.
Sure.
Okay. I'm still beginner, so be forgiving of that. So if I go to any of these links, for example, I could click on them, and I actually go to where that link would have been on Hacker News. If they happen to have a link that, like this minimum viable products question, it will actually try to go to a URL that doesn't exist because it's not a fully qualified URL. I'm not going to address that in this presentation. So now that I have one side, so this is the newest stuff. I want to get the front page too. How easy is it for me to expand to do that? Well, to go to my Hacker News stuff, what I can do is get home page. I can copy paste. And I think it's just called news. And to verify, we compile, get home page. Yeah, it looks like it worked. It didn't crash, so that's good. Now that I've reused the code that I made before to process it, because they use identical generation for their newest page and their news page for their HTML, I can now essentially do the same steps to make a top rated. So home page. I can go to my view template and essentially do the same thing. Top rated today. And there it is. I now have a section on my homepage here of my application that actually has the top values on Hacker News. And just to verify, news.ycombinator.com. I can't actually see the thing because this thing's in the way. But anyway, solar roof, beware of transparent pixels. Solar roof, beware of transparent pixels. So it's clearly getting the right stuff. Now, if I refresh this page, I'm scanning my server, but I haven't really caused much to happen over here. So you can see that Phoenix is logging that I got stuff, but the actual logger that says I'm requesting Y Combinator hasn't happened. That's because I'm referring to the cache I have in memory, which is what I want. So now you can see I just finished answering that page, but in the background I'm scraping it again so that if I refresh one more time, it would have the very latest. So that's just how my library works, and I've just demonstrated how to integrate several libraries, including one that you might make on your own GitHub, in order to basically get information from what could be a database or a service. You could use a library called Poison to do JSON processing. I'm not going to get to that because I haven't actually got anything together to extend to that point, but this concludes my presentation on how to make a toy application that uses multiple libraries together with a little bit of extra supervision, and finally giving back useful results if you're going to take something similar to what you make.
Also, Hacker News with no comments.
Yeah, no flame wars. No Vim versus Emacs.
This is great because I've gone through like the Phoenix tutorial, but I think this path is more interesting. It raised more questions than just yeah.
Does your library have any Phoenix specific code in it, or is it just?
No, my library is very abstract. It doesn't even know how to make an HTTP request. I let you define that in how you implement the behavior.
It's basically caching a behavior.
Yeah, it's a caching behavior that allows it to throttle how often you request stuff and how you keep track of things that are stale. So if I change things in here to say I'm willing to wait 1 second for here and 1 second for there, and it's been 10 seconds, and I hit refresh, you're going to see this wait a while because it's been a while since it made a request, so it actually performs that request right now. But if I refresh right now, it's instant because it's using stuff that's in memory. At least recompile just so I make sure that it's using the latest stuff. Okay, it says it recompiled. Where did I save? What's the next question? Okay, so if I refresh right now, it's going to wait a while before giving me the answer, and it goes back to how my application works, or my library works. So maybe our dear friend here will be able to make Islake and Dota Frozen work again.
Yeah.
So if you want to deploy to a server, I can probably talk about that next time. I have managed to sort of do it. If you want to look it up, you can look up this thing called Distiller. I'm not spelling it right, but yeah, Google can fix it. So essentially all you have to do is add this dependency, call mixed release on the same platform that you're deploying to, and then it will basically give you a command that you can run to run it as a daemon or interactively. And now Erlang and Elixir does have the possibility to do live upgrades, but I have yet to even figure that out. So maybe I'll share that next time.
Could you talk a little bit about the supervisor stuff?
Sure.
That, like Joe, I think that is one area that I'm wholly unfamiliar with as a
Okay.
concept in general. Like, it's specifically just like you had to define one for the purposes of this example. What exactly did it do? Could you like just talk about what it does?
Okay, so I will try to break down a minimal view of what this kind of looked like. So going back to the application file in my lib folder, we have 2 children here for the application. Let's make a pane to the right to actually do some stuff in. Okay, pane to the right. And let's go back here. So I have my application as something running at the root. And I just specified that there are 2 children here, hacker, use the client spec, and this supervisor of an endpoint. Okay? Now, inside of my library, I actually, this is a supervisor in of itself. So it has a couple things. So scraper supervision. So this element here is actually a supervisor based on slow scraper, which has a queue, a supervisor for pages, and a supervisor, or rather a worker for each client. So this supervisor for pages will actually create pages ad hoc to hold the memory. So these use what are called agents, which are very simple servers that basically are like CRUD servers, which is you can read, you can put, you can modify, and that's it. And I have a little extra code that says inside of this this process, quit after you haven't been updated how many times that I said in my client spec. So each page or URL has its own agent. The queue is the requests of things that that are stale. So pages will not automatically refresh once they go stale. A user has to request it. And once that user request happens, it goes into the queue. Then the client worker eats from that queue. I made it so it's possible in the future for me to have multiple client workers, but for now, it's all just one worker. If I want to have multiple client workers, I would have to make a supervisor for that and have workers under it. So the endpoint, and this is just theory at this point, says that it connects with Phoenix to hook in basically a URL routing process and likely a rendering supervisor. And it probably has a pool of renderers inside. So by breaking this out, perhaps you have just one process to actually decide where to route things, and then other processes to actually do all the string concatenation and database requests and stuff like that. Pools of this type can be dynamically resized. At least things in other Elixir and Erlang applications behave that way. Again, everything under this is just my theory of what it is. So if, for example, this page decides to leave, the supervisor acknowledges it and it gets pulled from its supervision children pool, so to say. If a page crashes, it may attempt to recreate it, but because of how pages work, they require to have input data, and the information on how to acquire that data is actually from the worker, and that's not under the responsibility for this. So my supervisor for pages actually says that these processes are transient, which means that either transient or temporary. One of which says, even if it crashes, don't try to restart it. So if I go back to my scraper and I look at my client's stuff, so this is old and don't look at it. So if I look at my pages here, Supervisor, I have to initialize my Supervisor. I have to tell it how to look itself up, which is used by other things. This is not required by the Supervisor behavior, but it's something that is common if you want to use gproc. And then here I have simple one-for-one, which means that I here inside of my children specify the template to create, which usually is just of one element. I say it's a client page, and if it has to restart, it's transient, so don't add it back. If I want to add something to my supervision pool, I have my own function here that basically wraps up how to add to my supervisor. This is a PID, and you can get that PID by using whereis. So PID is a process ID, and this says, okay, start a child on this supervisor or this PID, and use these parameters to actually initialize what it says inside. So if I jump to my client page, I can see that it is, let's see here. Where was I? Oh, it's opening over there now. So this is a little wrong, I think, but it apparently works.
And page is your own concept, right? That's not a supervisor concept.
Anything that looks more complicated than that supervisor thing here is usually going to be a gen server, which you can think of as a worker. I'm not claiming my library is perfect right now, or it's perfectly clean to like show off, but it just happens to work right now.
So is this a work in progress? What's the next step?
So Slow Scraper, I guess is kind of incubating with my own little bot projects that are like scraping websites and sending me texts and stuff like that. As far as stuff with using databases like Ecto, I've been practicing on my own with Postgres. They have migrations, they have schema strategies and other kind of loading tools to ensure that you only load what you need to, so you don't have the n query plus one problem, where you basically make n queries and then you make n individual queries as you process those results. So I've got several things that I'm kind of working with this, and Slow Scraper just happens to be a very useful tool in between that I think is a little bit more publicly presentable.
Cool. So was there, did you make Slow Scraper because you wanted to build something in Elixir, or did you choose Elixir because there was some feature that allowed this to work better?
I wanted to use it as an excuse to learn Elixir, and I felt that it matched some aspects of Elixir well, which is abstracting away some logic and some supervision while still being scalable, so to say. So I'm still learning the space, and I'm trying to use this as a project to poke around.
How was the learning curve for you to like build out this library? Do you have experience with like Erlang before, or?
I mean, I read the book for Learn You in Erlang, but I haven't had any actual like project experience. So most of my actual I made an application and it runs and it does things is only in Elixir so far. But reading Erlang code and integrating it with Elixir code is pretty trivial. If you want to use Erlang code, which is what gproc is, you basically call the module. So modules are actually atoms, and functions are also atoms. But you can call Erlang modules directly, whereas behind the scenes, if I throw up observer, this will this is a little GUI thing that allows you to see the state of your application. So if I go to hacker page, I can see that all of these modules here actually have Elixir dot before everything. This is a hack they use to make sure that their modules don't collide with modules of existing libraries that are in the Erlang universe. So everything you make in Elixir actually has a hidden Elixir dot before it. And let's see here. So too bad I can't like scroll out, but here you can see that the endpoint has, I guess, one thing that manages a couple pools here. And then here's my little thing on the side that manages pages. So here's the 2 pages. One is probably the front page, and the other one is probably the newest page. So if I go to process info on one of those, I can start looking into information on it. So yes, it's one of the pages. How do I find out which page it is? I can go to state. And it looks like it's collapsed right now, but it looks like this is the front page. So this is an Erlang utility. So when you look at stuff inside this Erlang utility, you're seeing the raw value from Bean. You're not seeing how Elixir would format it. So you see a lot of extra stuff that you may not expect. One thing is that in Elixir, your strings are actually binaries, and to represent binaries, you have these double arrows, and that's just how it works.
Is this a useful tool for, have you found this to be a useful tool? I saw you doing a lot of just kind of logging as far as debugging goes.
It's useful to see if stuff is starting up right. I have yet to actually like see things work out in the most useful way. So when you go to like messages on something, you're seeing stuff that's yet to be processed. But since everything is processing so fast, you're not going to see anything here unless you have a bottleneck. And a tool like this will allow you to introspect the message queue or inbox of every process. And if you see an inbox that's big and it's not being continually emptied, then that is probably a bottleneck in your system if you're under high load. And Observer, I think, can run on a production server where it runs the client GUI on your own machine, but I don't know how to actually make that happen. It's just that it's possible. So that's about all I got, I think. I would like some pizza now.
Yeah, please.
Let's see here. I'm going to stop.
Yeah, that's great.
Yeah. Let's see, how do I stop